Hello and welcome to another episode of Ken Training, where we want to give you the training that you need to tackle projects like this one on your own. Today's training is going to be on when you need to clean out your refrigerator condenser coil because your refrigerator cabinet temperature is getting too warm. That's the exact scenario that we have right now in my house. I pulled out my refrigerator, which is right there. I pulled it out from the wall, and I'm going to show you the thermometer that I have inside the cabinet. And it shouldn't take too long to do this job. Hopefully I'll have it banged out in less than 15 to 30 minutes maximum, but I'm doing a video so it takes a little extra. And all you need is a couple of tools. For the only tools that I need is just this air compressor and this here brush, so that way I can clean out the coil. So I'm going to try to give you the best angle I can on the coils so that you can see that. I am going to try to give you the best video content possible in the shortest time frame possible, and I only ask for you to do one thing for me, and that is to smash that like button down for me right now. And with that, let's go on with the show. Alright, it's a warm summer day in Southern California. On my thermometer that I keep here on the first level, this is the base station, and then I have 3 remote sensors, okay? And for the outside sensor, it's remote number 3, which on this thermometer is this one right here, remote number 3. It's 93 degrees in the shade outside with 13% relative humidity. In the house right now, we're not running the air conditioning. It's about 83.5 degrees Fahrenheit at 24% relative humidity. So I know it's a hot day. It's a hot day in the house. Let's look at the refrigerator. All right, so on my refrigerator, it's a side-by-side with ice and water on the freezer side. Let's open up the refrigerator section. And inside here in the refrigerator section, I keep, next to my Coors Light right there, I keep a thermometer, and and it's telling you that when this section right here, the needle is hitting the red, you're getting too hot. You should be over here in the green, and if I can get this to zoom in, it tells you refrigerator right there is where the needle should be. So I know this cabinet temperature is a little bit too warm. That beer right there is not cold enough. Those are supposed to be the Rocky Blue Mountains, and they're just not blue enough for me. Alright, so here's the dust cover that goes over the front of the refrigerator. I just pulled that out, and now let's go underneath and look at the coils. I have a flashlight right here, and this particular flashlight, the Energizer flashlight, does not take batteries. You recharge it with a USB port right there, and let me tell you, you pick these up for about 30 bucks at the Home Depot, and they are fabulous, fabulous flashlights. So if you don't have one, you know, I totally recommend this flashlight. It's great. Alright, there is a picture of your condenser coil. Accessibility is horrible. Camera angles are practically non-existent, but basically I'm going to get the compressed air, and I'm going to put some eye protection on, and I'm going to take my brush and I'm going to stick it in there to try to make sure that those coils are as free as possible from dust and everything like that. We want this section to breathe. So while I'm doing the brush, I'm going to have the air compressor on it blowing away to blow all the potential dust out. If you didn't have an air compressor like the one that I have right there, you could use your shop vac, or even a leaf blower. Any type of a blower at all to blow the air off the coils while you're agitating it with the small brush right here in an effort to get those coils clean. We want this condenser to breathe, not to be choked down by dust, lint, and pet hair and all that sort of thing. Alright, here is the coil after I cleaned it out with the air compressor and the brush. You can see I tremendously cleaned this coil. at the very bottom right there, that manufacturer has got like some insulation in there, so it looks like that section underneath the coil is clogged, but that's the way the manufacturer has it. I don't quite agree with it because it seems to me it doesn't breathe 100% correctly, but that's the way the manufacturer wants it, and I trust that that General Electric did that properly. And this is what it looks like here in this section. I know these angles are terrible, but it's underneath the refrigerator, so it's very, very difficult to see in here anyway. So, all right, so let me show you the back. All right, so now that I removed the back cover here, and I have the refrigerator unplugged, I'm going to just blow this out with compressed air just to clean it up as best I can. All right, if you can see this in the camera, all the dust particles floating in the air. This is a totally dusty thing. I mean, I'm not going to put the refrigerator in the garage. I'm just pulling it out right here in the kitchen, and I just have to blow it and deal with it as it comes. So there's not much I can do about it. Blow it out, let it settle out, and then we'll clean the floor. I did blow this out here just using the compressed air. This is what it looks like after I blew it out, and also I cleaned out the shroud here that goes on the cover that goes on here afterwards. But if you can see, I got it definitely cleaner. Okay, I put my shroud back on. I do want to tell you, do not throw these out. You do want to remove them and reinstall them the way that they came off. You can see they serve a purpose, okay? What's happening is that the manufacturer wants the airflow to travel out this way and not that way. So it comes out and through and then out this way. Without the shroud, the air may not flow exactly the way the manufacturer intended, and your condenser won't work properly. So I just want to reiterate, you do want to keep this, you don't want to throw it out, and you want to reinstall it the way that you took it off. Alright, everything is all set back here. I'm ready to put the refrigerator back into its place. A couple of things about the back of my refrigerator. Number one, I have a Govee water sensor. I'll leave a link in the description at the bottom if you want to purchase those. But if there's a water leak from these water lines that are at the back of the refrigerator here, or from the water fill to the ice and water machine, anything leaks in this area and it leaks on this Govee. Let me just show you how that works real fast. If it leaks on top, the sensor right there will pick it up, and then underneath, these are sensors between here and here and here and here. And if this thing will send a message to my cell phone, as well as it will beep audibly right here, alerting us that there's a water leak at the refrigerator. So excellent investment, so in case you have a water leak and you're unaware of it. Number one, I wanted to show you that. Alright, the second thing I want to show you is my electrical line and my water line that goes to the refrigerator. I have a string connected to it, just Mason line string. And I'm going to hold these lines up as I push the refrigerator back, so this way these lines don't get kinked in back of the refrigerator. So I'll pan this back so you can see how I do that. Alright, I had the refrigerator off for a little bit. I know I'm in the red at about 54 degrees Fahrenheit, and I'm going to shut their door. Alright, so it's about 5:35. I'm going to set the timer for 30 minutes and we'll see if the temperature drops. Alright, it's only been about 15-17 minutes. Let's see where we're at with this. It's dropping, but ever so slowly. One thing I want to look at is I want to make sure that the vents are open. There's one vent right there that's free to open, free airflow I should say. And then I'm just going to check, this back vent here, this box is kind of blocking it. I'm going to move it. There's the back vent right there. I'm going to move that just out a little bit so that way the airflow can travel in the back a little bit better. And I want to keep the door closed as much as possible. So I'm going to give it another 30 minutes. Alright, there's the clock. It's almost 7. Let's see what this refrigerator is doing. And it is dropping ever so slowly. Now I haven't changed the settings. We're still on setting 3 for the freezer and setting 3 for the refrigerator. It tells you here what section the this particular thermometer, the thermostat rather, is doing, and it tells you whether you want to go warmer or drop the thermometer down, making it colder. I'm going to drop that down. I know my condenser coil is clean, and I'm going to drop that down. I'm going to see if I can get that. I want to get that into the blue zone. It's 9:30 at night, and there's our support staff over there helping us with this project. And it's still not in the blue zone where I want it to be. It's dropping, but ever so slowly. We'll check it tomorrow morning. One other thing that I did was I changed the setting from 3 to 7 for the refrigerator to get it to drop colder. So even though the coil is clean, I want that to drop into the blue. Alright, last night I could not get the refrigerator to get to the right temperature. It's the next day, it's about 6:30 in the morning. Let's open up this refrigerator again. And we're actually not exactly where we want to be. We want to be below 40. So I'm going to drop this now to the coldest setting the refrigerator will allow, which in this case is number 9. And I'm going to see if that'll work. Okay, it has been about 24 hours since I cleaned out that condenser coil. So it is, let's see, 20 minutes to 4 o'clock, and let's go see what we got. Now I want to tell you what the outside air temperature is, number 3. It's 87 degrees outside. I moved remote sensor number 2 from the 2nd floor and I put it in the refrigerator. So it's currently saying the refrigerator is at 43 degrees Fahrenheit according to this thermometer. Okay, so let's open up the refrigerator, and I also put one of these thermometers, which is a meat thermometer here, and it's saying that it's 20 degrees Fahrenheit. That's not accurate. It's definitely not 20. This one over here is showing right at 40 degrees Fahrenheit, and if you look at the beer, those are the Rocky Blue Mountains telling you that the beer is at the right temperature. So this is that remote sensor number 2 that I told you I put in here, that I showed you. So this is remote sensor 2. So I believe that we're right about 41 to 42 degrees Fahrenheit, right at the upper end of the scale. So I'm going to consider this completed. Oh, one other thing that I did. I had to drop the freezer down to get to this temperature. This was at 3 over here, and I changed it to setting number 5. So I had to lower the freezer section. You can see here that it deals with the freezer. And I also have the refrigerator section all the way on section 9 in order to get just to the upper end of the scale. So I had to do a bunch of adjustments here. Look at that, just leaving the door open, I'm raising the temperature up just as I'm doing this video. Okay, let's talk about next steps for this project. So I feel comfortable that I've reached the refrigerator cabinet temperature of 40 degrees Fahrenheit. As you know, I've got 3 thermometers in the refrigerator cabinet, and over the next 24 hours I'm going to be monitoring that temperature very closely. Now, if the temperature still begins to climb up to a level that I'm uncomfortable with, the next step for me to correct this issue is to take the freezer thermostat setting and continue to lower it. I have it set to 5, but I've got 2 more settings before I'm maxed out on the freezer. By lowering the freezer temperature, that will correlate and also lower the refrigerator cabinet temperature. So if the temperature gets higher to a level that I'm uncomfortable with, I'm going to lower the freezer thermometer down lower. If I get to the point where that thermostat is completely lowered all the way to the lowest setting, which is 9 on this GE refrigerator, what I'm going to do then, well, then I have to do the thing that I'm completely regretting, which I'm going to have to put manifold gauges on the refrigeration circuit, and I'm going to have to see what's going on with the refrigerant. I know that the compressor is on. I know that the evaporator fan motor and the condenser fan motors are on because I can see and hear them. So so the refrigeration circuit is working properly. I just fear that possibly there's a small leak that has bled out of the system. This refrigerator is probably 20 years old. I didn't even buy it. It was here when I bought the house over 10 years ago. So I'm assuming the refrigerator it's 10 plus years. I'm not sure the exact age. So anyways, those would be the next steps if the refrigerator does not maintain a cabinet temperature that I'm going to be happy with, which I want to be about 40 degrees Fahrenheit. Ideally, I want it to be between 38 and 40 degrees Fahrenheit. So 40 to 42 is at the upper end of the spectrum. I really don't want to go any warmer than that. And you saw how warm the cabinet gets just by leaving the door open for not that long. So you as the refrigerator operator, your goal is to open it, get your product, and close that door as soon as possible to keep that refrigerator temperature at temperature. So basically that's going to conclude this video. I hope that you have gotten something out of this video. If you have, please click that like button for me right now. Subscribe to my channel, Ken Training. I will catch you on the flip side.